A language model is a pure function. Tokens in, tokens out. The instant the response finishes, it has forgotten you exist. Every API call starts from absolute zero. Fine for a chatbot. Fatal for an agent. An agent that books travel over 3 days, or pairs with you on a code base for months, cannot start from zero on every turn. The thing that makes a stateless predictor behave like something that knows you. That's a layer you bolt on the outside. We call it memory. And here's the part the AI discourse keeps dressing up in cognitive science words. Memory is a database problem. Storage engines. Indexes. Latency budgets. The delete. Underneath episodic recall is a question every back-end engineer already asks. What's the access pattern, and which store serves it? First instinct is always the same. Just put it in the prompt. Paste the whole history, the whole profile, the whole corpus in the context window. This fails for 4 concrete reasons. 1. It's finite. Even a 1,000,000 token window is a hard ceiling. A long-running agent will hit the wall. The only question is when. 2. It's expensive. You pay for every token in the window on every call. A 6,000 token prompt replayed thousands of times an hour is a line item. 3. It rots. Lost in the middle is real, and bigger windows didn't kill it. Stuffing 200,000 tokens in doesn't mean the model uses them. 4. It resets. Close the session, and it's gone. Working memory is RAM. Long-term memory is disk. Confusing the two is the original sin of agent design. So memory is the disk tier. Keep the window small and relevant. Page the right facts in from durable storage, exactly when they're needed. That's the RAM versus disk hierarchy an operating system already manages. It's the exact analogy MemGPT drew when it kicked off this whole subfield. Now, there isn't one kind of memory. There are 4. The CoALA framework formalized them for agents. Working memory. The context window, plus the scratchpad. Volatile, in flight, this turn only. Episodic memory. What happened? Past events, tool calls, outcomes. Last Tuesday, the user rejected the blue variant. Semantic memory. Facts. Stable knowledge. The user is vegetarian. Their company is on AWS. Procedural memory. How to do things. Learned skills, refined instructions. In practice, the system prompt that evolves as the agent improves. The mistake almost every team makes? Collapsing all 4 into one vector store and calling it memory. 3 different access patterns. One index can't serve all 3. Memory has 3 moving parts. A write path, a read path, and a consolidation job running between them. Write path. After a turn, decide what's worth remembering. Extract facts. Deduplicate against what you store. Resolve conflicts. The new fact might contradict an old one. Then persist. The hard part isn't storing. It's deciding what and when. Store everything, you drown in noise. Store nothing, you've built a goldfish. Read path. Each turn, retrieve the memories relevant to right now. Rank them. Inject the top handful into the window. And this runs on the critical path of every single turn, which makes its latency your latency. Consolidation. The background job that turns raw episodes into higher-level memories. The Generative Agents paper, Stanford Smallville, called these reflections. The agent reviews recent events and writes a synthesized observation. The user consistently prefers terse answers. Consolidation is a batch job. It does not belong on the hot path. Now the storage zoo. And the rule is simple. Pick the store by access pattern, not by hype. Vector database. Semantic recall. Embed the text, search by nearest neighbor. Find memories similar in meaning to right now. Vector, quadrant, weaviate, pinecone. Graph database. Relations and time. Entities and the edges between them. What does the agent know about this entity and its connections? Neo, 4J. And the agent native one, graffiti. Key value store. Raw episodic logs. Full transcripts. Cheap, append only, retrieved by ID. Redis. DynamoDB. Plain object storage. Relational database. Structured facts with constraints. Preferences, entitlements, settings. The boring, correct choice for anything with a schema. Postgres. This is polyglot persistence, the substrate. Where the bytes actually live. Postgres for facts. A vector index for recall. A graph for relations. The normal end state, not over-engineering. Hold that picture, because in a moment, something sits on top of it. Let's talk about vectors. Because they're the default, and they're overrated as a complete answer. Embeddings capture meaning. You retrieve them by approximate nearest neighbor. Almost always HNSW, a navigable small world graph that trades a little recall for a lot of speed. Here's the cost the slide deck skip. That index lives in RAM. At tens of millions of vectors, it's tens to hundreds of gigabytes of memory you pay for, continuously. And cosine similarity is not relevance. Cancel my subscription, and renew my subscription, sit close in embedding space. They mean opposite things. The fix is what search engineers landed on years ago. Hybrid retrieval. Sparse keywords for exact terms. Dense vectors for meaning. And a re-ranker to order the merged list. Pure cosine top K is a demo. Hybrid plus re-rank is production. Pvector, or a dedicated store. Start with pvector. One fewer system is worth a lot. Split it out when index size or filtered search load actually hurts. Not before. Now the two things vectors handle badly. Relationships. And change. Relationships. The user's manager is Dana. Dana owns the billing account. Billing is past due. That's a graph traversal, not a similarity search. And change is where most memory systems quietly break. Facts have a lifespan. The user works at Acme, was true, until last month. A naive store keeps both the old fact and the new one. Retrieves whichever embeds closer. So your agent confidently says the user still works somewhere they left. The serious answer is bi-temporal modeling. Track when a fact was true in the world. Separately from when the system learned it. Now the agent can answer where does the user work now, and where did they work in March, without contradicting itself. Conflict resolution on write. Detecting that a new fact supersedes an old one, and invalidating the old edge. That's what separates a memory system from a pile of embeddings. Here's the part that confuses people. The stores we just saw, vectors, graphs, key value, relational, that's the substrate. You still don't want to wire the write path, the read path, and consolidation across all of them by hand. So by 2026 there's a layer that sits on top of those stores and runs the whole loop for you. It's not a replacement for the database. It's the orchestration above it. Letta, formerly MemGPT. The OS analogy made real. The agent pages facts between an in-context core and external storage, by itself. MEM0. A drop-in layer that extracts and consolidates facts across sessions. Replaces full history replay with retrieved memories. PowerMem, from the Ocean-based team. Apache licensed. 4-way hybrid retrieval, vector, full text, and graph. Plus Ebbinghaus-style time decay, so stale memories fade the way human forgetting does. ZEP, built on Graffiti. And yes, Graffiti is the graph engine we put in the substrate. That's the point. The layer doesn't invent new storage. ZEP wraps that graph with the write and read paths to give you temporal knowledge graph memory. The strongest answer for relations plus time. And the cloud runs it for you. Amazon Bedrock Agent Core Memory. Fully managed. Short-term session context and long-term memory that auto-extracts preferences, facts, and summaries. No infrastructure to operate. One last distinction, because it trips everyone up. Managed does not mean layer. Pinecone is a managed vector store. You still hand it vectors, so it's substrate. The same tier as pvector, just hosted. Agent Core is a managed layer. You hand it a conversation, and it runs the whole loop, storage included. Same cloud bill. Opposite tier. And the assistants shipped it natively. ChatGPT has memory. Anthropic exposes a memory tool and explicit context management. This stopped being research. It's table stakes. So here's the one slide. Memory turns a stateless model into a product that knows you. Underneath the vocabulary, it's a database problem. Pick the store by access pattern. Vectors for meaning. Graphs for relations and time. Key value for episodes. Relational for facts. Treat retrieval as hot path latency. Run consolidation in the background. Model time bi-temporally, so old facts expire. Isolate tenants like a security boundary, because it is. The model is rented and stateless. The memory is yours.